All right, pre-calculus fans, here's the Wednesday video you never knew you needed. We are talking today about finding horizontal asymptotes of rational functions. And we saw this particular rational function in the Monday-Tuesday lesson. And we see that we have a vertical asymptote of the y-axis, or x equals 0, but we also have a horizontal asymptote of y equals 0, or the x-axis. And it's because as x gets bigger, so that's what this says here, it gets bigger either in the positive or the negative direction, your y values go to 0. That's what this says. This is actually describing end behavior. And if you think about it, 1 divided by 1 is just 1, but the bigger numbers you divide 1 by, the closer it gets to 0. Like 1 divided by 1,000,000 is really close to 0. So using this, we're able to develop some rules to find the horizontal asymptotes. And these rules you'll want to put in your notes. So let me see if I can make sure they're all in there. So when we're talking about rational functions, so right up here, this is the definition of a rational function. Each of those are polynomials, p of x and d of x. We're only going to look at the leading term, or the first term, just like we did in long division. And with that, we're going to look at the exponent associated with the leading term, or your highest degree. So this is your highest exponent. So if the exponent on top, so n is the exponent on top, is less than the exponent on the bottom, then there's a horizontal asymptote at y equals 0, otherwise known as the x-axis. And so our original function like this is a good example. We don't have an exponent on top, or the exponent is 0. Here we have an exponent of 1. So n on top, you could think of this as 1x to the 0. Remember, anything to the 0 power is 1. This is n, and this is m. So in this situation, n is less than m, and so we would have a horizontal asymptote at 0. Now, if my two leading exponents are equal, there's going to be a horizontal asymptote at the ratio of the coefficients. So here, I'll put an example. If we had something like 2x to the third all over x to the third, n equals m, because 3 equals 3, but this is my a term, and this is my b term. So now my horizontal asymptote is 2 divided by 1, or just 2. And then finally, if we have n is greater than m, so something like this, so this is n is 4 and m is 2, the graph has no horizontal asymptote, and that's when we talk oblique asymptotes, which will be an optional video next Wednesday. All right. So pause if you need to make sure you get all these down. Understanding that n and m are the exponents and a and b are the coefficients, and then these three rules are really important. So maybe pause and get that down. All right. So we're going to find the horizontal asymptotes of these two functions. Looking at f of x, and we've seen these functions before, we started with these in the Monday-Tuesday lesson. These are my leading terms. This is my ax to the n, and this is my bx to the m. So in this situation, n equals 1 and m equals 2. Those are my exponents. So this is an n is less than m situation. Now, if you go back to the rules, let me bring them up right here. If n is less than m, there's a horizontal asymptote at y equals 0. So in this case, my asymptote is y equals 0. It's going to be the x-axis. Now we come over here to g of x, though, And here's my a x to the n and b x to the m situation. We see that my exponents are 2, so n equals m in this situation. And if we look at that rule, remember that rule says if n equals m, there's a horizontal asymptote at y equals the ratio of the coefficients. Well, in this case, we know a is 1 and b is 1. So if I want to find my a over b, it's going to just be 1. So my horizontal asymptote here is y equals 1. All right. You may want to pause and make sure you understand all this, compare it with your notes. I had to add one more thing to this. Now, when we looked at some of the graphs on Monday, Tuesday, we saw that some of the graphs never crossed the horizontal asymptote, but some did. Now, remember, we can never cross the vertical asymptote because that's where the graph is undefined. But it could cross the horizontal asymptote, so we need to check for that possibility. And when we check for that, we set the rational function equal to the new horizontal asymptote. So that means we're going to set our function equal to 0 in this case, because remember our horizontal asymptote was 0, or 1 in this case. Now, if we get a solution, that means that the horizontal asymptote is crossed at that solution. So let's see what that looks like. In this situation, we're going to set 2x plus 3 all over x squared minus x minus 20 equal to 0. And remember, whenever we cross multiply these, this whole denominator is just going to like disappear because anything times 0 is 0. So we end up with 2x plus 3 equals 0. And if I subtract 3 from both sides, I'm going to get 2x equals negative 3, so x equals negative 3 halves. That means that you have a point on your graph that because I was able to solve for x, that we do cross the horizontal asymptote, and we cross it at negative 3 halves 0, otherwise known as our x-intercept. And that makes sense because we already said that our horizontal asymptote is x-axis, and we have an x-intercept, so we will cross on this one. All right, so let me see if you can get all of that in your notes. So now on g of x, we're going to set this whole function equal to our new horizontal asymptote we just found in the previous slide. So x squared minus 2x minus 15 all over x squared minus 4x plus 4 equals 1. And so if I cross multiply here, or multiply both sides by this whole denominator, I'm going to get x squared minus 2x minus 15 equals x squared minus 4x plus 4. And now I need to solve for x. So I'm going to get everything on one side, well, at least all my x's. So I subtract x squared. That's going to add to be 0, and I add 4x. So right now I'm going to have these cancel out, and I get, excuse me, 2x minus 15 equals positive 4. And now if I add 15 to both sides, I get 2x equals 19. So x equals 19 halves. And since those equal each other, since I was able to get a solution, I am going to cross my horizontal asymptote at 19 halves, comma 1. That'll be a point on my graph. All right. I'm going to stop this video now. If you guys need more examples, please come to my Wednesday office hours, and then we can answer your questions. Let me go back, make sure you guys get the top part of this slide. So you might want to pause it here. And here's the work for the bottom half. So once you find your horizontal asymptote, you set your rational function equal to that and solve for x. And if you're able to get a value, then it does cross. Hopefully we can look at some starting Thursday, Friday that don't cross and what that looks like.